Hey everyone, today we're going to look at a sample problem. This is a short version where the work's already complete. I'm just going to walk through my work and color code the steps that you see on the left. There's a full version of this from start to finish with all the math included. That'll be linked down below. So step one is always to convert zone time to GMT. To do this, you take the hour of your DR position, the minutes of your chronometer, and then you apply your zone description and the speed that the chronometer is fast or slow. So we're gonna have GMT of 14:52:12 on 28 November. This is step one here. Step two is to find your declination. The way you do that is you take your GMT time, go into your nautical almanac. We are at 28 November at 14:52. So 28 November at 14, our declination is south 21.2. South 21.2. So this is going to be step two, finding declination. Step three is to correct declination. The way you do that is you take as you get further along, so we're at 14, the next lower is greater of a number. 21.7 is greater than 21.2, so we know our correction is going to be added. And at the bottom of your page, we have a D of 0.4. So you write plus 0.4. The next thing you'll do is you'll go to the minutes and seconds and correct that if it needs to be corrected. Our increments and corrections at 0.4 for V or D corrects to 0.4. So south 21.2 plus 0.4, this is our corrected declination. The next thing you'll do is if the amplitude is observed on the visible horizon, you will correct your shot. So in the north, which we are through our latitude, and the amplitude is rising because the sun rises in the east, our bearing is close to 090. So we're gonna north rise add. This is our corrected shot. The way you do that is you take your declination and your latitude. For me, it's table 28 in Bowditch volume 2. It may be different in yours, but you go across the top with your declination down the column for latitude, and you see where it lines up for your correction. If we were in the south and our shot was in the west, we would be also adding this. So just keep in mind that this is the metric by which you'll go for applying your correction. Our corrected PSC is 103.6, so that's step four. Step five is to plug what we've solved for into the formula, which is sine amp equals sine dec over cosine lat. This is this progression where amplitude is 27.33 degrees. Step four is convert this to true. The way you do this is that when we're in the east, like we did with this correction, we're rising and our declination is south. That means we're going to be in the second quadrant, which would dictate us to have 27.33 plus 90 for a true of 117.3. The last step is to solve your DMC-T VMDC progression. Right here. We solve for true 117.3, 16.3 east. As we go further away from T, we subtract. So our M is 101, and we've corrected our C in step four. So 101 and 103.6 is a difference of 2.6, getting greater. So our deviation is 2.6 west.